About today's speaker, Kayla Robinson. She is a data scientist at American Family Insurance with 6 years of experience working with machine learning and data analysis. She is passionate about data transparency and volunteers with Code for Chicago. Today's session is about building your own dataset workshop, data wrangling and processing with public APIs. So over to you, Kayla.
Great, thank you so much, Anjali. That was really nice. Yep, like she said, today we're going to be going through a sort of like coding workshop. So I'm going to share a link to like the framework of a notebook in Colab, and then we're going to sort of go together and fill it out and build some data using APIs. So I'm going to start. I have a couple slides to start us off. Okay, cool. So a little bit about myself. So like Anjali said, I'm a data scientist at American Family Insurance. Before becoming a data scientist, I studied physics. So I did undergrad at USC, and then I did grad school in medical physics at U Chicago. And I think sort of like a lot of people in the field, it's been like a little bit of a winding path into data science. I know when I started in school, I like at first thought I was going to be a physicist and do research in like theoretical physics. And then I went to grad school thinking I was going to be a medical physicist and work like in cancer research in a hospital and be a good clinical physicist. And then just sort of discovered data science and machine learning as a field and found it was something that I was really passionate about and enjoyed. And then, you know, kind of here we are today. So whenever I'm like in listening to talks and stuff, I always like to hear a little bit more of like the speaker as a person. So I live in Chicago in Illinois, and a little bit about me. Everyone always asks like, oh, what are your hobbies? And really my hobbies are just like trying new hobbies. So like I thinking over like the fun things I've like been spending my time with the past like couple years. I like I've had phases with like knitting and embroidering, reading, baking with sourdough bread, felting, like different like exercise. So I just like to try new things and like just continue like new experiences. I think this is like my hobby. I also have 3 cats, so if we're lucky, some may make an appearance in this webinar. We will see. And another fun thing about me is that I'm a data scientist by day, but on weekends I work at a local brewery in Chicago. All right, cool. So a little of the goals of today, some things we're going to talk through and hopefully walk away with learning a little bit more about. So first, we're going to understand some cases where, like as working as a data scientist, when like it might be useful and make sense to pull in external data. We're going to learn how to make API requests using Python. We're also going to work with joining together multiple sources to make one like enriched data set. And then also going to practice some quality checks and data cleaning because we live in the real world and real world data is never perfect. So another kind of essential skill for data science. Okay, so for setting the stage, this is like the scenario that we're going to be working through today. So this is like a little bit of kind of like fictional backstory that we're going to be addressing as we are building up our own data set using APIs. So we are all data scientists at a fictional travel website. So imagine that this is a website that maybe helps web visitors to this website plan travel to new places. Maybe it also helps people that are like moving to new countries. So this is sort of like the genre we're going with. And so you are a lead data scientist at this company, and one of your responsibilities is in customer analytics. And so for what we're going to work on today, the business team has asked you to gather data about visitors to their website, so that we can better understand, like who is visiting, what are they interested in, are there any like differences or similarities, to just better understand the customers, and maybe, then the content team can make better content and all that good stuff. So they hypothesize that maybe there's different travel preferences based on maybe like the weather where people live. So maybe people that live in really cold places perhaps want to travel to warm climates, or vice versa. And then also just kind of like explore other trends, but from characteristics of their home countries. However, part of the challenge that we're going to specifically be focusing on is this company does not actually collect any data directly about their visitors other than the IP address that they're coming from. So even though we want to learn about like the climates people live in, or what kind of countries they are coming from and these characteristics, our company doesn't have that yet. All we know is like these are the IP addresses that people visited us from, but we want to do more. So how can we answer these without having any data sort of handed to us? And I think this is definitely a very real scenario that working as a data scientist, you're sure to encounter. You sometimes maybe have data, but a lot of times it's not complete. It's not everything you need to answer the questions that you're interested in. So I mentioned that this fictional website, that they have IP addresses, and that's sort of like what we have to work with. So what is an IP address? It's a unique identifier of any internet connected device, and it helps you send and receive information, and it's also assigned per network connection. So because of this, with an IP address, you know some information of the device you're connected to, and also the network it's on. So you can get some information about like the geolocation of this device. And it's not part, it's at first when I like started reading about this, I was like, oh, this is kind of creepy. I don't want people to know exactly where I am. It's a little bit coarse, like you might say, oh, this person is in this like general zip code or this general city, which is useful, right? Because if we want to know like what the visitors are to our website, maybe knowing about their cities is good enough. It's better than nothing. It's a good starting spot. So as a data scientist, we've maybe, excuse me, talked with the business partners and settled on a few different pieces of data that we think we can collect based on these IP addresses, and that might be useful for downstream analysis. So these are the genres of data that we are going to use external data sets and APIs to collect today. So first is the location. So right, like our website, it's about travel. We want to know where people are living that are visiting the website. So we could, either just like understand this better or give them tailored content. Next, we want to collect the current weather for our visitors. So like I said, maybe people with cold climates want to go warm places. Maybe people who are in very warm places want to go cold, just wanting to understand this. So that like in the analysis, we could look into that. And then also a little bit more like on a bigger scale, another thing we're interested in is pulling in migration rates of different countries. So a migration rate is like the number of people that move out of a country versus moving into a country. And so our, maybe business is interested in helping understand this as well. So there's another piece of data that we're going to pull in today. All right. So now we're going to get set up into the coding. So, so we'll share a link to a Google Colab notebook in the chat. Cool, thank you for posting that. So you can go to this link and it will ask you to sign into a Google account if you're not already signed in your browser. And then to do your work. And if you would like to save it, you can make a copy of it in your Google Drive. So I'm going to jump over to Notebook and I can show you a little bit of how to do this. So when you follow the link, you should land on a page that looks like this. And this is the Notebook. And as we're going through, please, if you have any questions or something's looking different to you, please drop a question in the chat or in the Q&A, and we will help make sure everyone's kind of able to follow along. So once you land here, if you'd like, you can make a copy of it on your own Google Drive so that you can save your work and be able to reference this in future and have a copy of everything that you've put in today. So to do this, you can go to File and click on Save a Copy in Drive. And then what this will do is it will just make a copy of it. You can see it called a copy of Build Your Own Dataset. And this copy is now in your personal drive, so you can do whatever you need to it and it'll save all of your changes. All right, cool. So first, let's get started. So the first thing that we need to do is to, there's a couple of different libraries that we're going to use. So I just kind of wrote for us a couple of cells to install these. So you can, on the first cell, you can just hit run. And what it's doing is I put the list of requirement files in this Git repo. And it's just copying that onto Colab and running an install of all the packages that we need. So can see that it installed and this succeeded. So then this second cell, I also wrote for us, you can just hit run. And what this is doing is importing the different packages that we're going to use today. So, all right, now for the fun part. So first, wanting to kind of look at IP addresses a little bit more. So for first, what we're going to do is use an API to tell us what's the IP address of your personal computer. So this and all of the APIs that we're going to use today, they're all public APIs, so available for anyone. And then one other thing I'll mention too is sometimes with APIs, you need to have your own sort of credentials or your own special key, kind of like a password to use it. But for today, to make it a little easier, so you don't have to make 1,000 accounts, I found and selected APIs that you don't need a key or anything. So these are things you can just call without needing to make an account. So this API that we're going to use first it's super simple. You just make a request to it and it tells you your IP address and nothing more. So when I'm looking at using different APIs, I always like to look at their documentation and see what are the parameters that I need to send to it and what kind of things might I expect to get back from it. So you can see here in the documentation that they have a few different API endpoints you can go. So you can just go to their basic one and it'll give you just the text back of what your IP address is. They have other ones where you can ask for specific formats that you maybe want to get the IP address back in. So yeah, so that's a little bit about what we're going to be using for this first one. So, all right, so let's get into it. So the first cell I have here is, you can just run this. It's just making a variable with the URL for this API. And then next we're going to do is make a request to it. So one package that I installed for us is called requests. And it has a lot of functions to help you just make calls to different APIs. So first we're going to do is we're going to make a request to the API and take back the result and save it into a variable. So that we can use and inspect it. So the method we're going to use is called the get. So I'll show you this function get is you can see it sends a GET request. So like if you go back to here, let's see if it talks about it. Well, so you can see like the different parameters that you can pass in. So the first parameter is URL. So that's right. This is the URL for the API that we have here. And then there's a couple other optional parameters. So sometimes, and we'll see this in some of the other ones we're going to work with, but you can also, if you need to give in certain parameters, you can list these in. You can ask for a certain pass in like certain data depending on what it needs. But for this one, you can kind of see like from the example, there's no like special parameters that you need to pass in. So we don't have to worry about that for this. So you can use. All right. So we can use this function and just pass in this URL. So you could use a variable, you could type in the string if you prefer. But yeah, so then now it's taken the result and we have it in this variable response. So congrats, you've made a call to an API. Next, I want to look at a little closer, like what is this response? What is it telling us and how can we use it? So first, one thing I always like to look at when I'm hitting an API is something called the response code or the status code. So this is information that tells you about like the success of your request, or if there are any errors or issues, it tells you about these as well. So the kind of like what I like to see is a 200, which tells you that your request was successful, everything went as planned, and that basically like saying that the results are like success and they're giving you back what you needed. If there's other kinds of errors, you guys can look through this. I put the link in the notebook, but there's other types of errors that you might get that give you some information. Instead of just saying like, oh, error, it can tell you a little bit more information on what type of error so that you can, go back and try to fix how you're making the request or what data you're passing, or understand like why it's failing. So let's look at our request and see what our status code was. Okay, cool. So this tells me we have a 200, which is good. That tells us that it was okay and that it was successful. So with that, let's start looking in and seeing what this actual response contains. So I think it's interesting to see there's, you can like, depending on your need, you can handle the data that it gives back in a couple ways and pull in different formats. So first, I'm just going to like a simpler, it's like not as useful, but it's helpful to see like what the kind of raw response looks like. You can just pull out what's the text from the response. So this is saying, oh, here you go. This is like the text form of what it gave us. And this is I guess this is my IP address. So so it's cool. It's neat that it kind of worked. And then next, another option could be to put the response into JSON format. So oh no. Well, okay, I think actually for me it was not working because the text is just a string. I could have put in an extra param of it's fine for us, but like you could have passed in, like when we were looking here in the documentation, you can just, I think because we just asked for just like a basic call, it just gave us the string. If we had asked for the format to be JSON, it would have given us as like a JSON format. So it's a little the nuances of this API. So yeah, so let's see, let's change it so that we get the JSON. format equals JSON. So I just added this tag on, and then now I can see the text now. It looks more like the what I'd expect for JSON. So it's like a dictionary with IP and then the actual value. So now what I'm going to try to do is put this as JSON. Okay, cool. So now you can see, if you look kind of closely, so when we ask for it as text, you can see it has like the single quotes around it, and then this is just a string that it returned. But now when we ask for it as JSON, it's actually a dictionary. And as a way to kind of like check this, what we can do, we can actually print out like what's the type of this response.
Kayla, could you quick scroll up to the top again and show the input with the format? There you go. Yeah.
Yeah, thanks. So yeah, all I did was I took the what was in the original notebook and then added question mark and then format equals a JSON. And again, what I sort of found that from was I looked at in the docs here, because I was now wanting a JSON, I looked at, well, what's the API URL for this like specific format to get back. Cool. And then, yeah, then so now if you do that, you can just rerun the request the same way, run the other cells and to see and sort of like validate like, oh, is this actually giving me a dictionary and not a string that looks like a dictionary? I put in this print out of what is the type when I call resp.json, and I can see it tells me that it's classes of dictionary. So this is good. So like matches what I expected. All right, cool. So now we have this IP address and I'm just gonna make a new variable to hold on to this so that we can use our IP as we're going through and like using some of the other APIs. So let's create a new variable. We'll call it IP. This will be just for our personal IP address. And I'm gonna take JSON dictionary. And then I just want to get the value that has a key of IP. So I can just index the IP off of this. Okay. And then just to make sure, I always like to make sure that, so I think that this variable IP will have, right, like this number address as a string. Let's just double check. Cool. So if that worked for you, it should have printed off your number is probably going to be different because you're on a different computer, but something that like is a string of numbers that's sort of with this format. Cool. So now you know your IP address.
And Kayla, just something that as we're going through that I think might be helpful. Do you want to just talk a little bit about like, is when we're hitting public APIs and REST APIs like this, is, you know, this kind of like a typical format that we get to that we'd be like dealing with these dictionaries and that type of thing?
Yeah, totally. And I think we'll kind of see like with some of those other examples too, but this is definitely like a simpler one. It's a dictionary, but it's just like one particular value because that's all it does. It's just built to give you your IP address, but depending on what you're looking at, and we'll see with some of the other ones we're going to use, those resources could get like a bit more values in it, contain more data. Was there anything else, Renee, that you wanted to add with that?
No, I think just kind of like that relationship between JSON and then getting it to the Python dictionary, that type of thing. But like, you know, you've got in here the converting it in here. So that makes sense.
Yeah, exactly. Yeah. And I think too, like, especially when you're getting a response that's like a string of a dictionary, like that, if you just keep it as a string, that's pretty tricky to work with in Python. So that's why I think it's pretty typical and a good idea to use this like JSON method so that you convert it into a dictionary. Now it's just like a lot easier to pull off, just give me the IP and don't, or whatever, like the specific field you're interested in is. Yeah, cool. No, thanks for asking that. Okay. Cool. So now we know our IP addresses, and with our sort of like scenario, we were saying, great, like let's say that our maybe the website on its backend could be doing something similar to this or something different to collect these numbers for all of the visitors to our website. So you can picture like the data set we're getting just has a list of these numbers for each visitor. So now to me is sort of like the exciting part. Well, let's start finding out more information off of this. So for this, we're going to use a different API to get the location or like approximate location of visitors just based on their IP address. So this is one I found is IP Geolocation Api. And here they have an example that if you put in an IP address, so I'll just pull in the one that I got here as an example. You can see more than like our last one just had one field. Now you have a whole bunch of more information. So just based on this was the IP address I passed in, it tells us, what continent am I on? What country am I in? What region? I guess this is like what state, what city, and even an approximation for latitude and longitude. So these are all just like information based on this IP address. And something I'm noticing actually is, so since I'm running that notebook and that call I made from in a Google Colab notebook, you can see like the organization is seized as Google Cloud in Google Cloud Platform. So if you're also running this in a Colab notebook, you might see something similar too if you put it in here. Right, so this is how it works, and this is a little of like the information we might expect. So this is an API demo. I also want to look at their documentation so we can see like when we call the API, is there any particular format they expect or variable names when we make a request. So let's see, so for geolocation, we talked about wanting to use JSON for this. So you can see they have a couple parameters, fields, response fields. So like if there's specific, maybe we just want certain variables back from the API, we could ask this or ask for it in a certain language. And similar to the last one, you can see that it says there's no API key required. So very commonly APIs will ask you to make an account and have your own special key so they can keep track of who's using the API, but this one's public and doesn't have this requirement, so easier for us to play around with. So we can look at their example here. So to make your like formatting for making a request, you can see they have the URL. Then they specifically point you to the JSON endpoint so that they know to give us back the information in JSON format. And then here is the example of their IP address that they pass in. And then you can see this is the return data format. And if we want more info, you can see they give us like a dictionary. So a lot of information. We won't be using all of this, but the fields that I think will be most useful for us are going to be latitude and longitude. So you can see like the name. So I'm expecting when we make our call, we should get back a field called lat and a field called lon. So let's go ahead and make a request here and see how it works. So here I already set up for us the kind of like formatting of how we will make the call. So this is the API URL. You can see it's like this part of it here, and then it has a slash and then the IP address that we're interested in. So I set this up just as an F string, so you can use these brackets are just saying, whatever my variable is, that's IP, which we set up here, it's just going to fill that in. So for me, for example, if I run this, then I can look at what's my URL, and it took my sort of like statement and then put in the IP address that I had up here, just kind of in that template. Okay, cool. So kind of like what we did before, we are now going to make a call to this API in a really similar way. So what we can do is, just like before, we're going to use the function get and pass in this URL. Okay, see green check, so something happened, but I still want to make sure, I always like to check the status code again, just to see like, was it successful or did it give me back some kind of an error? Because even if as I make a request and it maybe something funky happens, the get function still could succeed, and just like it's you didn't get an error calling this, but it gave me back an error code in the contents. So that's why it's always good to check. So I can look at status code. Okay, cool. And just like before, it gave us a 200. So this tells me what I sent in. They're telling me that, yep, what we're giving you back, it's successful. This is like a valid request. So that's good. Now let's take a look at what the contents are that it gave us. So you could do the text version, but I'm just going to jump straight to JSON and see what this looks like. Let's see, so they're giving me, okay, this kind of matches what we saw in like the demo of the API, but it says I'm in Charleston, from the Google Cloud, and it's giving me these fields, which I think are very useful, is latitude, longitude, and they're approximate. It doesn't know exactly where I am, but it has like general approximation of, like where is this city or where is this network centered. So these are all info that we can pull out and use. We want to see maybe where our visitors to our website, can picture, like we want to see a map of where they are or something, we could use their lat long and make a plot of this. Or if I want to see like what's the most common city people are coming from, I can look at the different values for city for all the visitors. All right, so let's use this and create new variables that are just pulling out, kind of like when we were doing the IP address, we just pulled out the string for IP from this dictionary and saved it for later. I'm going to do the same thing, but for latitude and longitude. So I'm going to make a variable called lat, where I'm going to just take this JSON and just pull out the lat variable. And same thing for long. And then I'm just going to check. I think that so lat and long should be just floats or just like these particular numbers, but let's check and make sure. Yeah, so latitude now is just a number. And longitude matches up with the -80. So now I have these variables stored and I can use them like down the road when I need to know like what my location is. Okay, cool. So this next, so since this is something that we kind of did by hand for just like the IP address we had for ourselves, since in this workshop we're going to be not just making like data on one IP address, we're going to be going to collect data from a whole number of IP addresses, right, for all of our visitors. So next what we're going to do is we're going to take these same steps that we just did, but put them into a function. So this way it'll be a lot easier to to not have to, write out the call to the API for every person. We can just have it sort of like wrapped up together into one function. So I put sort of like the start here, but we're going to fill the rest in together. So I'm calling this get location info. And the way I want this to work is if you give it the IP address, so just like that string, this function should make a call to the location API and return back that data from the API as a JSON. So let's do this together. So this is the same URL from above, but now we're just going to add in the same steps in this function so that we have it templated. So just like before, we made a new variable called rest. And passed in the URL. And then after passing this in, what we did was we put it to JSON. So, and then when it's all done, we want to return back this result. And now I'm just going to do a test of this, make sure that it's actually working as I expect. So to call this, let's do get location info and pass in just my string IP address. So I'm going to go copy and paste that. Let's see. So this was my IP address. So you can just type in the one I put or type in your own, either way will work. And if this works as I'm expecting, I'll get back a copy of that like full location dictionary. So let's see. Okay, cool, it looks good. So I'm getting back this dictionary and it has all the contents, including this latitude, longitude. So I like to put these things into functions because I think it'll be helpful that, when I'm writing code to like make this data set, I don't have to like type out like the API URL. I just have this function get location info, and I know if I give you an IP address, it'll give me back all the location data. So, okay, so we started with just an IP address. We're sort of like building up more information. So now we know a little bit more about the user. We know where they are. And now we can use this information of where the user is and build even more on top of this. So now we're going to start getting into local weather. So here we're going to use another API. This one is all kinds of weather data, more than we probably need, but it's always better to have more than not enough. So this API gives you weather forecasts, no API keys required. So there's a whole bunch of weather APIs out there, but I picked this one just because it had no API key, so it'd be a little quicker to use. But if you have more time later and wanted to play around with some others, I think it could probably be kind of fun to see some other stuff. So let's pull up the documentation so you can kind of see what we need to pass in and the type of information it'll give us back. So let's see. So these are all the parameters. So these are what we can pass in. And something I'll also point out is the column required. So this is telling us, do we need to pass this in, or can we skip it and it'll have some like default behavior. So first thing that this API requires for us to send in is the latitude and longitude. And it expects us to send in floating points. So like a number like with a decimal. And so that's kind of great because that's, as we pointed out on the location API we were just working with, it gives us back this information. It's already a floating point. So once we have numbers from that, we can sort of like chain that on and use it to get weather data with this API. There's a couple other optional ones. So, you can kind of like look through this, and if there's anything interesting, you can also add it in, but you can ask for hourly, daily. You could maybe specify a certain unit. So it, for example, for temperature, it defaults to Celsius, but if you want it to be Fahrenheit, you can ask it to give you Fahrenheit. All kinds of stuff, whatever you sort of need. And then I also want to look at what it's going to return to us. So here's an example of what the data is going to look like when we get it back. So it's going to repeat back, like, we gave it our latitude, longitude. It's going to come back and say, hey, here's the latitude and longitude you gave us. And then here's some extra information we see about this location. So we can say, oh, here's like its elevation. Here's a list of temperatures. Here's temperature units. Here's the current weather. So you can say, oh, like right now at this particular time, the temperature is 13.3 degrees Celsius. Wind is 10.3 kilometers per hour. It looks like its default unit was, and all kinds of other info. And they also give you more sort of like detailed info here. So this is a little bit of what we have. So let's test it out and let's pull some info from this. All right, so first we're going to make a call to this API. For this one, since you could see it had a lot more parameters, there's a couple specific parameters that I wanted to pass in. So this, okay, I'll pull up like so we had the documentation for requests get. So we've been using this URL. Just send in a URL and see what it gives us back. But now we're going to use this params as well. So params, it's a dictionary to send in the query string. So what this means is any of these input parameters that we want to pass. So like passing in the latitude, longitude, and current weather, anything we want to specifically ask for, we can put in to a dictionary in this call to the get function. So I set up a couple that I thought made sense, but like after this workshop, feel free, play around with some others and see what else you can find. So the first things I set up was the required ones. So it required us to give latitude and longitude. So I spelled those out, latitude, and I used lat, which was the variable we made before. I set up longitude, passed in the variable we had before as well. And then the next thing I specified was current weather. So looking at this row, this is a bool, so it can be a value of true or false, and it tells the API whether I want to get back the current weather conditions. And I thought that would be something interesting to pull out because, like, I think it would be interesting to say, oh, when our visitors are visiting our website, like, are they visiting it on a rainy day? Are they visiting on a sunny day? And getting track of this information it'd be interesting. So I thought, yeah, it defaults to false. So the default is that I won't give you this back, but I just said, hey, yeah, I want to get this back. And then the last parameter I set up was to ask it to give us back it in JSON format, just kind of match along with everything else we had been doing before. So you can just run this cell that I wrote for you, and it will just set up what the URL is and make a dictionary of the parameters. And then next, we're going to actually make a call to the API with URL and parameters. So same way as before, get URL just like before, but this time we're also going to pass in params. You can run that. Okay. Cool. And I'm a broken record now, but I also want to look at the status code so we can see, did I mess anything up or did it work? Okay, so we got a 200. Again, that means that it was successful. So this is good. Next, let's look at what the results are for us. So just like before, we can say, great, give me the results as a JSON. Okay, cool. So then here's what we're looking at. So this is a dictionary, and it includes a dictionary of the local weather. So here they're saying this is our temperature in Celsius at, you know, May 7th, 1500 hours, all this information for this particular latitude longitude that we got from the IP address. So you can kind of see how, like, at least in this case, we started with very limited data, and we're sort of like using these to build off each other and chain up to get like more and more detailed information. So now we know kind of a whole lot about this person. So all we started with the IP. Now we know they're in Charleston, South Carolina, I think it said. And we know what their weather is. So this is starting to get a little bit more interesting. And now we have more data that we could do analysis on or understand the customers and visitors to our website more on. So kind of like last time, I want to put this into a function. This way we'll make it easier to when we want to chain this together for a whole bunch of people. So I set up kind of the structure of this function, but we're going to plug in the actual call to the API together. So in this one, I have a function, get weather info, and the inputs to the function, it's going to ask you for the latitude and the longitude. I changed it. Okay, to change, I just realized a mistake. I had long, which is not what we called our variable before, and also the data type of a long, so this could be cause a problem. So I would say change it to LON here and here. Sorry about that. But then, so you'll give it your latitude, longitude as your inputs. And then inside the function, it will look at our URL. It will set up the parameters. So it'll use the lat and long that you pass in these parameters that you can then send out to the API. Like in our other example, it's going to say like, yes, please give me the current weather formatted as a JSON. And then now what we can plug in is actually like making the call. So just like before, similar, you're going to make a response. You're going to use request.get, that same function. You're going to give it the URL, which it'll look at whatever URL we put in the function. And you can give it params, which will just look at, whatever these params have been set up as is what it will call for the function then. We can say, okay, we have our response. Let's look at the JSON part, like what we did before, and then return this result. So if it all works as planned, we give it in a latitude, longitude, and it should give us back something that looks like this dictionary of the current weather. Okay, so let's give it a try. Let's test and see if this works. So if I call my function, I can say get weather info. I can give it in my latitude and longitude. So my latitude was 32.875. My longitude was -80. And I can run this, and all right, that looks good. So when I ran this function, it set up the parameters, it hit the API, and it gave me back this current weather response. So this is great. So that's going to help simplify our work next. So, right, maybe this is a good place to pause. Were there any questions that anyone raised that we should talk through? Let's see. All right, cool. Yes, this will be recorded. Which link will be shared out after. Okay, cool. We keep going. So All right, so just to kind of summarize what we got, we had started with finding our own IP addresses, getting the location with one API, getting the weather with another API. And now for this next part, we're going to move into making not just all of this info for one person, but making it as a whole data set for like a whole list of visitors. And so since this is a fake website, so we're gonna have to actually start by making fake IP addresses to sort of be like stand-ins for these people. So I thought this was a good opportunity to introduce this library called Faker, which I think is super clever. It's basically, it has, I'll pull up the docs because I think it is really interesting, but it can do, basically it's to create fake data, and they support like all kinds. So we're going to be using it to generate fake IP addresses. But like anytime you need fake data for like testing functions or just like generating lots of like data that conforms to some kind of format, it's awesome for. So it can do like fake names and it will come up with like names that look realistic. What else do they have here? Fake addresses, just all kinds of cool stuff. So this is a little on that. The link is in the notebook, so feel free to read it after. But yeah, they have a method, they have a function to make fake IP addresses. So I was like, great, this is perfect for us. So we can start by making a faker object, and this is what will be used to generate the data. So you can type, we're making a variable faker using this library. Okay, and then once you have this, the function or the method to create an IP address is IPv4. And so I had to look this up because I wasn't sure, but I learned there's different like formats of IP addresses. There's like, I think V4 and V6, I want to say, but it will like format the number of digits a little different. Basically because how I read it is like we're running out of IP addresses. So they were like, oh, we need to make a new format so we can like fit more in. So that's like a little bit, but the format of IP we've been working before was this V4. So when I run this, what it will do is it will just generate a fake IP address, but that still like matches the format of an IP address so that we can use it in our analysis as if it were a real IP address. So yeah, you can see. So I ran this and it gave me, it looks like an IP address, but it just sort of is like randomly generated. And every time you run it, you can get like a different number. So if I ran it again, you can see it's still another IP address, but now it is changed and it's a different number. So basically what we can use, why I brought this in and we can use it for is it will generate for us, just make a bunch of calls to it and we can pretend that these are like the IP addresses for our visitors. So yeah, so wanted to introduce that concept and then that's what we'll be using. All right, so the next, what I want to do is basically take our functions that we wrote earlier in the notebook and use them together to make kind of like larger function that does all of these API calls, all of these processing for us. So this function we're going to write, I called it get geo weather data, and what it will do is if you give it just the IP address, so for example, like the string you get from here, it will just, given this IP address, will hit the location API, so we can get your location. It will hit the weather API, so we see the weather. And then we'll also want to take these two different responses and combine them together. So we have like all of this data in one data structure, so that it's cleaned and a little bit easier to use in our analysis. And then it will return back this set of dictionaries for this person. So once it's all said and done, this function will give us back for a certain IP address. It'll give us like a nicely organized set of location and weather data combined. All right, so let's get started. So first, we have the IP, so we want to get the location data for the IP. And so what we can do is, since we wrote the function earlier in the notebook, we can just reuse this. So let's say location info. In the function we had before, we called it get location info. And then this nice collapse gives you the type in. So you can see when we wrote this function, the only argument we have to pass in is the IP address. And so that's something that we expect them to pass in for this like top level function. So great, you can just give it the IP. Okay, so then now when this line's called, it'll take the IP, call the location API, give us back that dictionary had like your latitude, longitude, city, all of that good stuff. Next, we want to take, we use like the latitude, longitude from location and put that into the weather API. So what we can do is first want to pull out what was the latitude, longitude out of this location info, because that was the dictionary. So let's make one variable called latitude. And it was just pulling out the lat item from that dictionary. And can do the same thing for longitude. Okay, now we have these variables. And then we can pass these into our weather function that we wrote. So we called that function, it was called get weather info. And you can see here, it expects us to give two different variables and it wants us to give the latitude and the longitude. That's how we set it up. So great, we can just say latitude, longitude. Keep typing long, that's not what we called it. Cool, so then we'll make a call to weather and put the result of that into this weather info. So now at this point in this function, we've made two, we will end up with like two dictionaries. One is a dictionary of location info, one is a dictionary of weather info. And next, what I want to do to sort of like just make it easier to work with is to stack these dictionaries together. And so this is the syntax for it's a little funky, but I'll just call it all data for like weather plus location. So first what we want to do is I want to hold on to the IP address. So even though like we gave it in as a string, I want to put that into a dictionary just so we can stack it on with like the other dictionaries. So let's just make our own dictionary and we can call it IP. So like the key is IP address, and then the value of this dictionary would be like the IP string that someone gave us. And then this was new to me as I was writing this, I had to learn a little bit. So with the pipe character can be used to stack together dictionaries. So you can do a pipe, and then the next dictionary we want to stack. So the next one we want to put on is like the location info pipe, and then you can stack it with the other dictionary, which was the weather info. So with this, it'll put together all these dictionaries into a new variable called all data. So that's what we want to give back. So let's return all data. Okay, and then I'm going to add in call to this, make sure it works. So let's do a call to this get geo weather data. Okay, and then I'm going to scroll up. I forget what my IP address, or let's just use this fake one. So here was a fake IP address we got from Faker. Here we go. So we use this and run it through and see what we get. Okay. So I think, so one thing I know is that this was only good in like certain Python version. So what we can do is, oh, closing bracket. Okay. I think the closing bracket on this is okay. Let me try. Okay, so I had another, I was afraid this would happen, but there's another way of stacking dictionaries for older versions of Python. I wasn't sure what Colab would run, so we can try this. So we have our, okay, so this is like the double star is also an option to stack together. So I'm gonna try this, see what happens. Okay, I think that was it. So yeah, I believe the original way, this only works in Python 3.9.
Yeah, the Colab's running 3.7, just so you know.
3.7, okay, cool, beautiful. So I had a hunch. Okay, so the fun of writing a notebook in one version and testing it in another. So anyway, so this other syntax, it does the same thing, and you can kind of see that here, that we have our function, we put in the IP address, and it's giving us back stacked together all the fields from those different things we passed in. So, right, like these kind of first few, like your city, your country, those were all what we had from the location info API. The current weather, the elevation, those were things we had from the weather API. You can see the IP address, that's also something we had. So basically I thought instead of keeping them each as separate dictionaries, putting them together like this, it will help us just, you know, when we ultimately want to put this together to make it a data frame with it, sort of like does a little bit of that legwork for us. So yeah, here, this fake one was New Orleans apparently. But if you all had used a different IP address from Faker, could get something totally different anywhere in the world. So, all right, cool. So it looks like that's working. So next, this function I gave to you, but we can talk through what it's doing. So what I did here is basically wrapping the entire process of creating a fake IP address, getting all of this data, and returning back this result. But as I was playing around with this and writing this, we kind of found a couple like nuances. So I added some extra logic in here that I wanted to give you, but still talk through. So you can see, so I call get fake geo weather data because it's creating this fake IP address and then doing the weather stuff. But you can see that the extra argument I put in called max retries. And what I sort of found was that I believe what was happening was like that Faker is good at making fake IP addresses, but these other APIs we're using, like getting weather and location, like those are real. Like those only work if you give an IP address that actually corresponds to a real location. Otherwise, those IPs are, or those APIs are gonna give you back an error because it's like not valid. So what the extra logic I put in here was basically to do retries. So if you use Faker and if it gives you a IP address that's just like gives an error in some of these others, it will try again. It will make a new fake IP address, try again, see if I get like good results back, otherwise try again, and keep going up to this number of times. And if it gets something good, it just gives you back that good result and stops. The reason I decided to give a max number of retries instead of just saying like, try for infinity, keep trying until you get something good was like maybe I put a bug in somewhere, maybe I, used the wrong IP address format or something weird was happening and it made it so that like, or even maybe there was a bug in some of these other functions we wrote and like, it's just never going to give back a good result. I didn't want to like be stuck waiting for this never-ending process. So I said, okay, if I try 5 times, or you can change this number and however many, but if I try a bunch of times and it's still not working, just like tell me that the max number of retries were hit and just give me back nothing. So yeah, so that's what I popped in there. And so next what we're gonna do is, I think kind of like the fun part is we're gonna actually use this function, or okay, don't forget to run this cell because it needs to learn the function. And then what we're going to do is like call this function a couple times to get a list with a whole bunch of different information for people with different IPs. So let's see. So a couple ways we can do this, but one option is to use a for loop. So what we could do is, let's see, for I in range, let's say we want to start with like making 10 different, like we have 10 different random visitors that we want to do. And so what I want to do is I want to make a like list of weather, or list of, let's call it list of visitor results or something. And what I want to do is for each fake IP address with their info, I want to add it back onto this list or append it onto this list. So for each item for 10 times, I want to call my get fake weather geo. And I can just leave it blank because I have this default setup. So if I don't put anything in the function, it'll retry up to 5 times. I think that's fine. I don't need to give it the IP address because it creates that in the function. So then it has this result, and then I can just add this result back onto my list. So then what I'm doing here is I'm just saying, great, I have this list, add on my result to this list. So I'm gonna try running this and we'll see what we get. It might take a second because it's calling like several APIs several times. And then let's see, I want to see what the actual result looks like. So okay, it's long, it's a lot of info. So you can see it's a list and each item in the list, so like this is the first item. This corresponds to someone who's in the US with a temperature of 12.8 degrees Celsius. And this is their latitude, longitude. They're living in Ohio. So, okay, that's one person. Another person's in China. Someone's in Cupertino. And yours, if you use different, you're going to have all different people than me, but it should look like a list with a whole bunch of dictionaries in it. And that sort of kind of like a success for us. This means we got all our data for all of our visitors. So, okay, cool. So now, okay, so then, yeah, just to recap, so we've created our data, right? It's in this list. This is all the data. so far that we were asking for. We wanted to know their locations, their cities, and their weather. And that's all here. However, in data science, a lot of what we use are like pandas data frames is very common. And this list of dictionaries, it's a little bit harder to use for analysis. It's a little bit harder to plug right into a lot of the other tools that we use for like analysis or visualization. So next step that I'm going to do is to actually take this format, but convert it into a pandas data frame to make it easier for us. So what I'm going to do is make a new data frame. I'm going to call it DF weather. And it's actually so simple. When I first thought like, oh, it's like such a nested structure, like it's going to be complicated. No, it's you just create a pandas data frame, give it the list of dictionaries, which did we call it? We called it list of visitor results. So I just did pd.dataframe list of visitor results. And this will create it, put that same data into a data frame. So let's take a look at it and see what it looks like. Okay, so I just did the name of the data frame .head just to see the first couple of rows. So now I think this is looking like something that's going to be a lot easier to do our analysis on. So you can see there's a column of the IP address, status. Hopefully this is success for everything, or else it would not have given us data. You can see what are all the different countries that these visitors are from. What is their region?
Hey, Kayla.
Yeah.
We have a request in here. If you could copy that code you changed for the get weather data info. People are having trouble getting it to run.
Great idea. Yeah, let me put this into the chat. Thank you, Renee. Okay, yeah, there it is. Yeah, was it this one?
I think so. They're saying they can't copy from the chat, but my hope is that they'd be able to. Oh, they want me to copy into Q&A. Okay, I can copy from the chat. I got it.
Well, yeah, I think the main difference was this line, because yeah, I guess this pipe doesn't work in all Python versions. So basically just making a dictionary with the like the double star, and then each of those dictionaries that we either defining for like the IP or that we used a function above to create. Cool. All right, so next, okay, so we had created our data frame and I was just kind of like looking through it to just kind of like get a sense check, like, do these things match up with the right format, the right type of information that I think we should, and what might be useful to like down the stream. So you can see like what internet provider they were using. That's kind of interesting. And then here's some of this weather data. So you can see their current weather. So I think this one's maybe interesting to mention. So current weather, the way it is here was the weather API gave us like current weather was itself a dictionary. So that response, it didn't have each of these items like time, weather code listed out. So that's maybe one thing we might want to change, is that instead of having like a dictionary in our pandas data frame, we might want to split those out to be columns themselves, depending on like if that's like information that you want easy access to. But then you also see like their elevation. So are they like at sea level? Are they living in like a mountain region? That's all kinds of stuff that you now have easy access to. So yeah, so here's like a couple of things I thought that might be interesting. I ran these with only 10 examples. I'm going to try running it with a couple more. I'm just going to set it to run with 100 and see if everything still works, or maybe we might get something different. And also then we can start looking at things like what are the most common countries? What countries are we getting? What are the most common? Are people like, I don't know, start getting into like what you might want to start getting into like analysis questions. So it's taking a minute to run because now it's creating for 100 times the creating an IP, hitting all of these APIs, reorganizing the data, and putting it in a list. So while that runs, see, we only have like 10 minutes left in our time. So there's another section in this notebook that I don't think we have time to go through together, but I'm going to just talk about it like in a high level. And I'll also send you a link to a GitHub repo that has all like the answers to it so that you can kind of go through it yourself and check back on the code as you go. But this other set that we won't go through together, but I set up for you is everything we've done so far is calling APIs, but a lot of times data that you need may not necessarily make sense to get from an API. It may already be in like a spreadsheet or a CSV or some other tabular data that you want to sort of like add on to the other data you've gathered. So this last section that you can go through on your own if you're interested brings you through doing just that. So I have from the United Nations, they have, as I was looking through, they have tons of really interesting data. So one that was interesting to me that I chose, but you could do this with any, was this migration data. So it is, see, I'll pull it up, see if I can show you. I'm just pop over so I can show you the Excel sheet. So it's in an Excel sheet. Let me zoom in a little, and it shows you like for all different countries and regions, you can kind of see, here's like a list of a whole bunch of different countries. It shows you lots of different stats about migration rates, and even like in different time periods. So you can see like, this is like their most recent time period. And I can see like, are people moving into the country or out of the country on average? And it's per 1,000 people. So for example, like I can look at like Uganda, and if I scroll over to that column, that tells me that like on average per 1,000 people, 4 people are migrating. For 1,000 population, 4 people are migrating in each year. So it could, I don't know, it's like UN has also a ton of other options, but this was the spreadsheet that I pulled in to the code and joined into our other data. So I'll show you just really high level what that looks like in case you're interested. So it, here you can read in the data file. So I just passed in like the URL to that file. And other thing I'll point out is this skip rows. Basically when I had it, it was like there were a couple of rows in the spreadsheet that were just kind of like decoration or like logos. So I said, skip those, give me straight to the data. And then if you work through the rest of these cells, what you can do is our location data gave us the name of each person's country. And that other file also had a column of country. So what you can do is you can join on and say, oh, this person's in the US. What's the migration rate for the US? This person's in China. What's the migration rate from China? And then this way you can pull on extra external data to sort of supplement your supplement the rest of your data. So in our last moment, I'm going to circle back. And so I set it to run with 100. Let's see if it finished. Yeah. Okay, cool. So you can see very long here. There are at the end a few none, which this tells me is that the way we wrote the function was like, if it retries too many times, or if it retries 5 times and gets no result, it just says none. So looks like that happened a couple of times. So we can see, let's try taking this bigger data frame. Yeah, so here it doesn't like having the nones. So what I'm gonna just do is one line to just, we're gonna, the ones that didn't work. So we can take, I'm gonna say take the same list and just only take the ones that are not none. So I'm gonna say like visitor for visitor in this list if visitor is not none. And what this basically is doing is it's just saying, okay, yep, look in this list, we have our big list, go through each one. I'm calling each entry a visitor because those are like our website visitors, and add them onto this new list only if it is not equal to none. So basically just keep all the data entries that are like good data, get rid of the ones that aren't, and try running this again. So now our data frame should be have a bit more rows. So let's see, I'm just gonna look at how many rows. Yeah, so even though we asked it to run 100 times, it looks like after dropping the bad ones, there's only 89 left. So, not everything worked, that's fine. And then I'm just kind of curious, I wanna see like, maybe like what are the counts of the most common stuff, and then we can, so let's see. Let's look at what the most common countries are. So I'm going to say country, and I want to look at what is the count of the different country names over this. So I can see there are 36 hits from the United States, 9 people from China, 6 from Japan, 4 from Germany, so on and so on. And so just, kind of just like getting a little bit into seeing what this might be useful for. You can see how common people are from different places, all kinds of stuff from there. So I will, let's see, I think leave the rest as homework for you, especially after you join it with the, if you go through it and join with the migration data, there's some data cleaning, because when you pull data from multiple places, it never just works out. So some kind of code that can lead you through that as well if you want to learn. But I think that's a good place to end for this section. So, and I'll share a link to the GitHub with that so that you have also these answers.
And Kayla, at the beginning, some people had some questions generally about any tips you might have for cleaning data, like processes that you go through.
Oh yeah, that's a great question. So for me, I will say when I'm cleaning data, like the process doesn't start with cleaning the data. The process starts with like understanding what's messy about the data you have. So like, for example, you might come into, I remember one example is I was working with a data set that had a column for gender. And, maybe you come into that assuming, oh, like everyone's gonna have a gender of like male or female and like other or something. But when you start looking into it, there's, values like male, female, girl, boy, all kinds of different things that like are still like strings and maybe valuable, but until you look in and see like what are the values in this column, you just kind of like don't know what needs to get cleaned. So I would say, yeah, looking at like unique values in a column you're working with can a lot of times help you see issues that you need to clean. If you're working with like numerical data, a lot of times like looking at a histogram of it can tell you a lot. Like for example, maybe you're working with like company revenue or something, and you assume it's in dollars, but maybe it's in like thousands of dollars. And so a lot of times like those cleaning is involved in just kind of like checking what like you expect the data has, and does it have that? Do you need to make modifications so that it matches with what you need for your analysis? The other kind of tricky thing with cleaning data is always missing values. And so a lot of times the steps I like to suggest for handling missing values is first like identifying them, which is harder than you think. Sometimes they'll just be like a value of none to say it's missing. Sometimes you might see like the word like not available or NA as like a string. So like, to Python, it's not missing. It has a value of not there or whatever, but you as data cleaning have to like find those and correct them. And then also, right, how do you handle that? And that's going to be very like specific to your situation. Do I have a different value to fill it in with? Do I need to do something else? That all like depends on the scenario.
Kind of related to the cleaning up thing, one of the questions people had is like, how do you make sure when you're cleaning up data that you're not getting rid of stuff that you thought it was noise when it really isn't noise? Like, how do you avoid, like, one of the questions they're asking is like committing type 1 errors, but I think in general it's more just like when you're cleaning your data, how do you make sure you're not actually introducing more problems?
Yeah, I think that's a great question. And a lot of times too, I think that's sort of like part of the role of being like a data scientist instead of just instead of just being like a coder, is a lot of times you have to look past just the data you have and go like back to the source. And maybe you think that a value of -1 means missing, but maybe it really actually does have some important signal. And until you talk to the person who you got the data from or talk to someone familiar with it, a lot of times that's the best way to like truly understand like the meaning. So like, oh, it is noise, or oh, it is missing, before you like remove it or correct it. That's a good question. Right, cool. So I just wanted to give a little thank you slide. So thank you. Here is all of my contact information if you want to get in touch with me. This is my email, my LinkedIn. I love to connect with you. I'm also on the Women Who Code Data Science Slack channel. So it's just my name. Feel free to shoot me a message. I'd love to hear from you in chat. And then also, like I mentioned at the beginning, I'm a data scientist at American Family Insurance, and we have lots of open roles for data science. So you can either reach out to me, I can send you job descriptions if you're interested, or visit our career page. Yeah, thank you so much for taking the time to go through this. I hope you all enjoyed it. I think whether you're just starting in data science or just starting with Python, or maybe are a little bit more experienced, this is hopefully something to like dip your toes into and sort of like open up. I think a lot of times, especially when you're starting, you might just go to Kaggle and they have those, beautiful ready for you data sets that you just load and go. But yeah, I hope that kind of going through this, you can kind of see that there's also lots of opportunities to kind of think outside the box and like not just work with what's handed to you, but kind of go out and find what you need or what you don't even know you need yet, because there's a lot of data out there that you can get access to.
Thank you, Kayla, for the wonderful session. It was great. And thank you, Jesse and Ren, for answering all those questions. There were a lot of questions and they answered it very enthusiastically. Thank you, everyone, for attending the session. It was a great session. I learned a lot from it. So I'm sure everybody learned a lot. And okay, see you guys. Good night, or according to my time zone, it's good night. So good night, guys. Okay. Zareen, over to you.